in this last lecture from chapter 14 on linear regression, and also the last lecture of the course. We will explore two other variables that will define the extent or the goodness of a linear regression relationship. The first is determination. Similar to our work in the sum of squares values in ANOVA, we can calculate three values to define a regression model. SSR is the sum of squares due to our regression. You can see it's the sum of predicted y minus the mean of y squared. SSE is the sum of squares, and SST is the total sum of squares. The value r squared is called the coefficient of determination. R squared is simply the sum of squares due to regression divided by the total sum of squares. For the data on car sales and ads, we can calculate a coefficient of determination to be 0.87. For any coefficient of determination, an r squared value, the closer it is to 1 or 100%, the stronger the relationship. In this case, with an 87%, we can say that 87% of the variability in the actual data can be explained by our straight line least squares model. The correlation coefficient, r, is simply the square root of the coefficient of determination preceded by the sign of our slope. So for a negative relationship, we will have a negative value of r. For a positive relationship, we'll have a positive value of r. Both the coefficient of determination and the correlation coefficient determine the goodness of fit of the actual data to the regressed line. The closer either r squared or r is to the value of 1, the better the relationship. An r squared value of equal to 1 means a perfect relationship, and our regressed line fits exactly to all of the data. An r squared value of 0.5 or below indicates a poor or no relationship, but you can consider any r squared value above about 0.75 to be a reasonably good relationship, good fit.